You might have heard of MCP, but what is it and why should you care? In today's video, I'm going to clearly explain Anthropic's Model Context Protocol, and we'll get into a practical example. Anthropic developed MCP as a way of standardizing communication between AI systems and external tools and resources. Without MCP, the way AI systems would connect with external systems would require a lot of custom integrations and custom development, and that becomes very expensive. We're all familiar with USB-C connectors. Using the same connector, we're able to charge our laptop, our cell phones, our AirPod case, charger case, a lot of different devices, but with one simple connector. MCP is something similar to that. It simplifies the entire interface and makes it very, very easy for an AI model to connect to external data sources. The M in MCP stands for model. If you've used ChatGPT or Anthropic Claude, you're very familiar with LLMs. We're talking about the same model here. It's the AI large language model as far as MCP is concerned as of today. The C in MCP stands for context. Now, this is really a key concept in MCP. If you've used ChatGPT and Claude, you're very, very familiar with prompting, even DALL-E, right? When you prompt, you give an AI model very clear specifications and instructions for a task that you want it to do. The more detail that you give, the better the result tailored to your request. That is giving context to an AI model. The issue here is that the way you prompt ChatGPT and Claude is a very static process. For each task, you have to give one single prompt. And this sort of severely limits the capabilities of the AI models. MCP significantly expands the context capabilities by allowing AI models to access external resources and data sources, such as databases, APIs, real-time streaming live data sources, such as financial information, stock prices, crypto prices. This way, your AI models can now get real-time information and provide you a lot more tailored, relevant, and accurate response compared to a static prompt. This greatly expands the AI model's capabilities. The P in MCP stands for protocol. This is where MCP standardizes communication between AI systems and other external resources and systems. MCP clearly defines how AI models should request and receive data from external sources or use external tools. Without such a clear specification, you would now have to build custom integrations with a lot of different external systems, and that becomes very cumbersome. This is exactly where the USB-C analogy comes into play that we talked about earlier. Using the expanded context capabilities and a clear protocol definition, MCP really is a game changer for AI models to really now access a wide variety of data and become a lot more powerful. Let's talk about the MCP architecture. It's a very simple client-server architecture where MCP clients are embedded within host applications, such as the Claude desktop application or the Cursor IDE. MCP servers are unique to each external resource or service that it connects to. But the client-server connection follows the MCP protocol. So it's very easy and it's very standardized. As you can see here, this is the MCP documentation. I'm going to put a link in the description below. It's a really good guide. Here, the client connects to a lot of different servers. Each server connects to a unique resource and talks its unique language to return that data in a standardized format. There are different ways of providing context to a model using this architecture, such as tools and resources. These are really the two primary ways when it comes to MCP in which you could provide context. Tools or external services and systems such as databases, APIs, like weather systems or financial data or analytics engines that you could interact with and provide context to your LLM model in a more real-time and a fairly nuanced fashion. Resources can be local resources or even remote resources such as Word documents, presentations, or other data sources that are fairly kind of static but not as complex, such as tools. So yeah, really these are the two ways in which MCP servers, a wide variety of MCP servers, can talk to the standard MCP clients and then provide context to your AI models. These are really the different directories for MCP servers and clients, and I'm going to put links to these resources in the description below as well. This pulsemcp.com is a fantastic resource for server and MCP clients. Let's talk briefly about the protocol implementation. MCP basically uses two standard transport mechanisms: standard I/O, which we're all pretty familiar with, command line or shell scripts, or any local interaction typically uses standard I/O, standard input-output. Alternatively, you can also use server-side events, or SSE. This is where server-to-client streaming communication happens. When a client typically communicates with a server, they can use HTTP POST, for example. We're all familiar with HTTP POST. When you submit a form on your browser, that uses HTTP POST to take data from your browser and post it onto the server. Using SSE, you can use server-to-client communication when streaming is needed. For example, we talked about real-time financial information, weather service, crypto pricing, for example. You can build custom MCP servers that send real-time streaming information from server to client using SSE. Now, this is really where MCP shines. It really opens up a lot of possibilities. You could build, for example, systems where you could interact using Claude desktop to interact with an external service and say, hey, give me, using the real-time financial information, stock information, for example, tell me which sectors are doing the best right now. Or analyze sectors that might have a dip right now. Analyze some stocks that might be buying opportunities. I'm just giving a very, very high level information, but you could build complex systems using something like an SSE. So it's very, very powerful. Now, both standard I/O and SSE are slightly higher level transport protocols. They both use JSON RPC as a lower level wire transport. JSON RPC is a very simple protocol that enables you to build SSE and standard I/O slightly higher level protocols. Now, let's get into a practical example. Let's say I want to interact with a local database, and using the Claude desktop IDE, I want to use natural language to interact with my dataset locally, which means instead of using SQL, I just want to ask it standard questions. And let's see how the Claude desktop IDE interacts with our local database and gives us results. So I am using the NBA database from Kaggle. Kaggle is a pretty cool community for data scientists and machine learning enthusiasts where they could participate in competitions, they could learn about AI, ML, and they have a lot of data sets. So I'm just using this NBA open source data set. And I'll put a link in the description as well. And if you scroll down a little bit in the NBA SQLite data set, there's a download button here, which I have downloaded locally. So let's look at the terminal. I have downloaded it in this location here. So it's a nba.sqlite file, as you can see here. So now that I've downloaded the SQLite dataset, let's go to the MCP server directory and look for a SQLite MCP server. And when you look for it, the Anthropic SQLite shows up. And it'll point to a GitHub repo, which you can fork locally. So I have the official Model Context Protocol servers GitHub repo here, which also I'm going to link in the description below. And I have checked that repo locally. So basically, you could clone the Model Context Protocol servers repo locally. And within that, there is a SRC or source folder. Once you go in there, you'll see a lot of different sources and servers. You could go into SQLite. And that's where the SQLite source code, MCP server source code lies. Great. So I have that cloned locally here. Now, let's connect our Claude desktop using the MCP server. So for that, let's take a look at the Claude configuration. So I'm on a Mac and I have downloaded Claude, and this is the location. It's within the library application support / Claude folder. If you're on a PC, that might be on a different location, but on a Mac, it's within this location. Under that location, I've created a Claude desktop config JSON file. You can copy my standard configuration here. It's very, very simple. It basically says that I have a SQLite MCP server, and I'm going to give it a bunch of arguments. It's going to use a command called UV. If you don't have a UV command installed on your Mac, you could simply use Homebrew to install UV. You could just do brew install UV, and that should be it. And basically, it says that using the UV command, I'm going to give the directory where the MCP SQLite server lives. And using that server, I'm going to give it the database path. And this is the same path here where I've downloaded my NBA SQLite data source. So this is the config. And now let's go to our desktop client and then see if it connects. So you should see this icon right here, attach from MCP. Once you click on it, you'll see installed MCP server. If you have multiple servers installed, you might see a list, but I have installed the SQLite MCP server, and that shows up here. So let's interact with our Claude desktop IDE. Okay, let's ask, show me the winningest, W-I-N-N-I-N-G, winningest team and NBA team in the last 5 years. So I'm basically just asking it and assuming that it knows how to connect to my local data set. Let's see what happens. Okay, so now it's asking permission, allow for this chat. So it took a bunch of read queries to understand the data set first. That's why I had to do a lot of like list tables, describe tables, and then do a bunch of select stars or any select queries so that it got a decent understanding of the data set. And this is really, really cool. So it actually wrote a quick script to show us that data as well. And mind you, this is a bit of an old data set and also kind of static. And based on that data set, it got this response. Really cool. All right, that's my take on the Model Context Protocol. If you have any questions, please comment below. If you got value out of this video, please like and subscribe and hit the bell icon for notifications for future videos. Thank you.